Okay, I think so. You can start. If they join in the meantime, I'll do a recap. Okay.
Yes, sir.
Okay.
Like might be today, couple of people might not join, I guess.
Yeah, it's fine. So, good morning to all of you. Last week we saw how to handle exceptions, and there is a small part which is remaining. We shall try to explore that today. Sometimes there is a need to nest the try-catch blocks, the way I have shown you in the code here. That there is an inner try-catch block and there is a outer try-catch block. Now, sometimes the errors that occur, they will be of multi-level in nature. You have to handle some part of it in the inner catch and some part in the outer catch. So let's see how we can do that. For instance, the same banking application, if you take, you have balance, amount and all that. So here we can read the amount. So we can give a cout, enter amount to withdraw, and you can do a C in here and then read the amount. Now if balance minus amount is less than 1000, you want to throw an exception. Okay, so here you can throw one of the known exceptions like runtime exception, runtime error, and you can say transaction paid insufficient balance. The else part you can carry out the transaction. So balance minus equal to amount, and you can create transaction successful, balance, and that. Okay, so in the inner catch, what I do is I only report that some error has happened. So here const runtime error ampersand e cout report error. So what is that error? You can get it from this e what handle. And once you know that the error has come up, you have to take some remedial action. So you want this to be done by an outer catch block. So what I can do is I can re-throw the same error from here. You just have to say throw here. So what happens is the runtime error is thrown to the outside catch block, and here you can handle this as a general exception or the specific exception. If you just say exception here, and here you can say cout. Of course, what message will be same, but the handling part is done here. Now in the handling part, you can ask the user to enter different amount and carry on with the next attempt to withdraw. Okay, so that can be one of the remedial action. We shall see how to do that, but now we have only this much. So in this case, what happens is uh, the inner try catch will report the error and the outer catch will handle it. Now the handling part we shall take it up shortly. Now if I run the program, the amount to withdraw, so initial balance is 2000. So if I say some 100 rupees, it will go through. Okay, transaction successful, balance is this. Okay, but if I enter an amount greater than 1000, then let's see what happens. So the inner try catch will report the error, transaction is paid insufficient balance, and error handler, the outer transaction will again tell the same thing, insufficient balance, transaction paid. Okay, so in the handling part, what I can do is I can ask the user to re-enter the amount in case he has accidentally entered 1200. So for that we have to set up a while loop here, while not success. So success is initially false, so it will enter this loop. So this will be continuously uh, run the loop until you successfully do the transaction. Now within this block, here in the handling part, you can declare a character choice here and see in, or first I see out, do you want to continue. So you can give yes no choice, and here you see in the choice, and if choice is equal to no, or choice is equal to no, then you break the loop. Okay, else you have to continue. It means again it will go back here, the while loop will continue. Okay, and if you are able to successfully do the transaction, you have to make, after the transaction is successful, this success variable set to true, so that it will not continue again once the transaction is over. So these are the small changes you have to do. And now you see the reporting is done by the inner cache, and the outer cache will handle it properly, and you will be able to continue with your transaction if whenever the failure occurs. So if I run the program, if I say 1200 error paid, insufficient balance, you will see all this. Do you want to continue? If I say yes, then again it will ask for the withdrawal amount. So here if I say some 500, then the transaction is successful and it ends. Okay, so is this part clear? Hello?
Yes, sir.
Okay, so would you like to try this out, or we'll continue with the next part? I mean, it's pretty evident, right? Inner try catch and outer catch block. I will share the source code with you. So we'll continue with the next part of our session today. All right. Okay. Now, what I wanted to cover majorly today is threads. Okay. So C++ supports concept of a thread. So as you can see, thread is a lightweight sub-process. So we know process is a program in execution. All of you have studied operating system, and operating system allows you to create processes. So I have symbolically indicated process in the oval shape. Now what happens is, if you try to execute everything in the same as a single process, many times you may have to do multiple things. For example, you have a browser wherein you want to download the file also at the same time you are playing the video also at the same time it is rendering some text, and in some part of the web page you are uploading an image. So all these things may be happening at the same time. So you do not want wait until download completes, or you do not want until the video play completes. You want to do all of these things simultaneously. So if you want to support such thing, then you have to use multi-threaded applications. So multi-threading improves the responsiveness of the applications. Now how all is this done, right? So in our C++ program, whenever you have main method or main function in C, this is the main thread. Okay, so only one thread will be there initially. Okay, so that is what is your process. So within, assume that this is the execution path of the main thread. It is executing one instruction at a time, and here there is only one execution time until this point. I can create separate execution paths within the same process. As you can see here, this is one thread, let's call it as thread 1, and this is another thread 2. So this part of the program and this part of the program and also the main program, all these can execute concurrently. Concurrently doesn't mean parallelly, but in interlude fashion, this will execute for some time, then control will switch to this, execute for some time, and again control will switch to this, and again come back to this, again go to this, again go to this. So all will be progressing simultaneously. Okay. Now if you have multi-core chips, like you have quad core or octa core, these threads can be running on different cores, and you can actually have a parallel execution of these these execution paths. So if you have threads, you will be able to run the programs faster, and you can do multiple things simultaneously, that is downloading a file also, playing video also. So you assign one thread to each one of these. So download file is done by one thread, playing video is done by another, rendering text is by another, uploading images by another. So 4 threads will be running simultaneously. If any one of them completes, fine, that will close, and the main will be running all the time. You can make this main to wait until all the child threads complete. Okay, so there is a method called as join. You have to execute this so that the main will wait until the child threads join back the main and the program terminates. Okay, so this is the concept of a thread. So let's see how we can create threads in C++. Is the concept clear, or you have some doubts here?
Yes, sir.
Okay. So let's see how we can do the thread creation. Now, to create a thread, you have to include a library. Okay, so whatever main that you see here, it is a main thread. Okay, I have written it as cout main thread here. Now if you want to create your own thread, in this you just say thread, give some variable name, thread like this, and within this you have to mention some function name, or you can write a lambda here. We shall see how to write lambda later on. Okay, so within the opening closing bracket we'll create a thread, and let us say this thread, I want this thread to say, let us say hello. Okay, and this say hello you have to write as a function here. So this thread will start executing, and if you want main to wait for this thread to complete, you say thread join. So the main will wait until thread 1 completes and then execute this statement. So let's see what happens here. So hello, I am a thread is executed, and then you will have this main thread ending here. Okay, so it's as simple as that. You can have any number of threads. You can, let's say hello, greetings, another. You can pass some message also here, and just say cout message and then like this, and I can create one more thread T2, and here you have to say greetings, greetings like this, and since it is accepting a argument, you have to pass a string object here. Let's say good morning like this. And this also can join the main thread later once it is done. So now there are two threads will be running parallelly. Okay, so hello, I am a thread, and then good morning. Two threads are running simultaneously, and the order of executions may vary. Sometimes good morning may come first, or the other way around may also happen, but if you try several times, all the time it is first thread is executing first. Okay, yeah. Now if I write this here, so main thread will also be doing its job. Okay, so as you can see, first main thread executed, then hello I am a thread executed, and then good morning is coming up and ending the program. Okay, so now if you look at this simplistic example, it doesn't make really any sense that you are just printing some messages, but these will be executing one after the or parallelly alongside. And
Sir, here when we give that C out in the beginning, like parallelly the main thread and the
yeah, now you see main thread is running. After saying main thread dot dot dot, it will switch to the thread 1. Okay, it says hello I am a thread, and then it will switch to the second thread T2, and it says good morning, and it will end the program. Okay, now let us see a more intricate one. Instead of just saying say hello, suppose if I write a loop here, see what happens. So I'm just printing 1 to 9 by this, and let us say this is printing something else, or int I equal to 1, I less than 20, I plus plus C out. Now you will see lot of mix up happening. See, after 1, this 1 2, again 1 2 has come. Okay, it's not 21 here. After 1 it is not 21. The 1 2 is coming from say hello, and immediately switch to the second thread. It will print 1 2 3 4 5 6 7 8 9 10. Okay, and it will just go on like that till 19. Then it will switch over to the first thread. 3 4 5 6 7 8 9 will continue, and then ending the program. As you can see, programming is running in a concurrent way. So if I run it again, you will see altogether different pattern. So 1 2 3 4 5 8 9 is going, and then again 1 2 3 4 5 11 up to 19. So now you see they are executing one after the other. So depending on how you run, the output behavior will be different. Okay, so you may get interleaved operations of thread 1 and 2. Okay, now it is streamlined. Now you can see again it is interleaved 1 2 3 4 5, and again it is starting from 1 2 3 4 5 6 7 up to 19 here, and then 6 7 8 9 of the first thread will continue. As you can see, both the threads are progressing concurrently. Okay, so do you have any doubts here, or you still have some confusions?
It is a bit confusing, sir. Maybe if we do, we will get a bit.
Yeah, you just try this out. Okay.
Sure.
Now instead of just saying say hello, what I can do is I will do a little modification. You can continue later. Let's say this is up counter.
Okay.
Okay, so it will go from 1 to, let us say, 50. And then let us say this is down counter.
Okay.
Let's remove this message now. It's not required. And here it will start from 50, or let's say 100, and I greater than 50. I minus minus. So this will come from 100 to 50 and this will go from 1 to 50. Okay, and here I have to remove this message and say this is down counter and this is up counter. Rest all remains the same. Now if I execute, you will see 1 2 3 4 5, then after 5 it is starting 199 like that. Now 93 it will go and then again it will continue from this 5 to 6 7 8 9 like that. As you can see, lot of interleaving is happening. So both are progressing simultaneously.
Okay.
Okay, you understood?
Yeah.
Yeah, just try this out.
Yeah. I mean, even if we are on 20 and 21, if you're calling separately also, you mean these two will run parallelly?
Yeah. The,
Okay.
T1 join, T2 join will make main function to wait until these two threads complete. Otherwise, what happens? The main will execute and it will end. So that is a incorrect scenario. No, somebody who has started the threads has to wait for the threads to complete.
Complete. Okay.
Sir, how the memory will be allocated, sir, for the, in this thread concept, for the main program?
It's the same way. I mean, memory for variables T1, T2, they are allocated on the stack, the reference variables. Sorry, these are T1, T2 are reference variables. Actually, they point to an object. Thread is a class. Okay, remember, thread is a class and T1, T2 are an objects now. So their object reference variables, they will be in the stack. Actual objects will be in the heap. And you are passing this functions as an argument. It means you should tell the thread what program to run. So I am asking T1 to run the up counter and asking thread 2 to run the down counter, and then main will continue and it will wait for T1 T2 to complete. So that is why that ending program will come at the last.
So the main thing here is that if we need parallel executions, we
Yeah.
use this.
You use threads.
Okay.
See, I'll give one more example. Let us say you have a server, you have a web server. Let us say Amazon. So when one customer contacts Amazon and if he's doing lot of things there, other customers have to wait, no? So what it should do, if there are 10 customers, for each customer it should generate separate thread. So that each thread will attend to different customers, so that every customer feels that server is dedicated to him. Okay. So it's a very larger concept. I have very simplified it to show you how parallel execution happens. Okay. Now both the threads are sharing the same screen. Okay, so that is why that overlapped output is coming here. Suppose you had two screens, okay, screen 1 and screen 2, and cout you can do to screen 1 and screen 2. You will see both these count values coming out separately, one down counter, up counter simultaneously. Okay, just try this out.
So that Amazon thing you said, so what I understood is, consider we are two people are placing order at the same time for the same product.
Okay.
So at that time this will be used, they'll create a thread.
Yeah. That each thread will attend to taking orders from each of the customers separately.
Okay.
Okay. Of course, there are some concurrency issues there, like only one product is left, so whom do you allocate?
Fine.
So in that case, we use what are called as mutex, the concurrency control mechanisms. I will show you how to do that. Okay, now see, I told you thread has to be provided with a function to tell what the thread has to perform. Now can I replace this function here with a lambda? Okay, so what I can do is, we know lambda is a anonymous function, so I can cut this and place it here. Okay, only thing is you have to prefix this bracket with a square bracket so that it will be treated as a lambda. Similarly, you can do it for the down counter, and you can remove this now. I'm just showing you one variation, that is inside the thread T1 you can specify a function name, or you can directly write a lambda function which does not have a name. So square bracket, opening bracket, and then all of this. So this time also it should run. Same thing can be done with second thread. You can replace that with a lambda. So this is one small thing you must note, that is it is possible to write the functions within the thread itself using lambda notation. So now I have replaced both of them with lambda functions. So this time also it should work. This is about how to use threads to do the operations. Now if I were to synchronize this, that I want up counter to run first and then down counter, okay, then we have to use what are called as mutex. So mutex is a mechanism to synchronize the threads. So first thing is you have to include, you declare a variable mutex, okay, and within this wherever you want, we have the thread T1 which is starting here. Here you have to do the locking. You have to say lock guard mutex like this, and then lock n. So what happens is the thread is locked now. It will not allow any other thread to run. Same you must do with thread 2 also, so that both the threads will be synchronized some way. So you will see up counter happening separately and down counter happening separately. Okay, as you can see, 1 2 3 4 5 up to 50 it will go, up to 49, and then 199 will start. So now you see the both the threads are synchronized. That is, I am putting a lock here, that is, don't allow any other thread to run once I have started. Okay, so when thread 1 starts, it will block any other thread to execute. Of course, you will not have parallel execution now, it will have sequential execution. Now you have to use locks only if they are required. Okay, so as I told you, if you are downloading the file, if it is not affecting your other activity, you need not put the lock there. Okay, another scenario where locks are to be used, as I told you, suppose you are reserving a seat on a train or a bus, so only one seat is remaining. So how are you going to stop two people from reserving the same seat? So once you enter the function reserve seat, there you have to put a lock like this, so that nobody else can reserve the seat. Okay, so there will be microsecond difference between two people trying to book that ticket, which is the last remaining seat on a bus or a train. In that case, the lock happens for one of the customer who is trying to book his ticket. So in that case, he gets the ticket, and other person will get a message saying that tickets are not available. Okay, so even though it is showing ticket available, but at the time of actually reserving, the difference of time is considered and the lock will be put, and accordingly the reservation will happen. Alright, so using lock guard, I can put a lock and make things work in the way I want. Okay, so this is another part to remember in threads. Okay, so let's seek a more useful example. Let us say we have a same banking application where I want to use two threads. Two customers are trying to alter the bank balance. Assume that there is a bank account which has a balance, and in the bank account constructor I am going to initialize the balance. There are two methods here, deposit and withdraw. Okay, so what might happen is one thread may be depositing and another thread may be withdrawing. So though both cannot happen at the same time. All of you agree? Isn't it? So we have to guard against deposit and withdrawal. So when withdrawal is happening, you should not allow deposit to happen and other way around. Okay. So the logic is simple. In deposit, you are simply going to add the amount to balance and say deposit successful. There are no errors happening here. But in the withdrawal, we have a condition that the balance should be above 1000 or equal to 1000 after the withdrawal. So that check is done, and if enough balance is there, you are going to perform that action and say transaction successful. So here again, if I want to guard against depositing and withdrawal at the same time, I should be using the log guard here. So I put a log guard here also. So the mutex has to be defined within the class wherever you are using it. And now in the main, I create a bank account B with initial balance, let us say some 2000 rupees. And then I create a thread T1, and within this I want to execute deposit. B1 dot method like this. You have to write a lambda here. So you have to pass the object B or just say ampersand, and within this lambda function you say B dot deposit. Let's say you are depositing 200 rupees and B dot withdrawal after some time, let us say some 700 rupees. Okay, so this is what thread 1 will be doing, right? Similarly, you can have another thread T2 which again has a lambda, and within this same object B, it's going to withdraw first maybe some 900 rupees and B dot deposit 200 rupees and maybe B dot withdraw 1500 rupees, something like this. So which of these operations will go through depends on how much is the balance at the time of executing. So both the threads will run, and here you can use again you have to say T1 dot join and T2 dot join, and here you can do cout. So now if you run the program, you will see the bank account operations will be happening. So first obviously deposit will be successful because it doesn't violate any rule. So 2000 becomes 2200. Then transaction debit will be successful because you are withdrawing 700 and it will leave the balance above 1000. So 1500 is the balance. But subsequently you are trying to withdraw more. Okay, it is saying transaction failed. So what might happen is you are trying to withdraw that 1500 rupees or whatever amount that I have left there. What is the amount I have given? I have given 900. Okay, so if we subtract 900 from 1500, it will fall below 1000, so it will not allow. Okay, then this deposit is successful because after the failure you are trying to deposit 200, so the balance will be 1700, and again when you try to withdraw 1500, the transaction fails. So as you can see, both the threads are executing simultaneously, and the lock mechanism will ensure that only one of them is happening at any given point in time. Imagine thread 1 is customer 1 and thread 2 is customer 2. Okay, or they are trying to access the same account. There is a joint account. Assume that there is a joint account and both the account holders are trying to do these operations simultaneously. So whenever anybody is doing withdrawal or deposit, the other person is blocked, and once they are done, it will go to the next. So as you can see, the operations are interleaved and both will be progressing in some random order here. Alright, so you will get almost the same effect. But suppose if I withdraw only 500, the last one will also go through. So 1700 will become 1200 at the end. Transaction successful, balance 1200. Okay, so threads are very useful, and we can build lot many applications. As I told you, bus reservation or train reservation application can also be built alongside with this to demonstrate how we can block two people trying to reserve the same seat. Alright, so just go through this example, and if you wish to try out, you can just give a try and see for yourself how this application makes use of threads to perform the banking operations. Alright, would you like to try this out?
Yes, sir.
Okay, so to summarize what we discussed today, that in exception handling, there could be a scenario where you may have to nest the try catch blocks. So in the inner try catch, you report the error, and the outer catch block, you actually handle the error. Okay, and we saw how to create threads. What threads are? Basically, threads are lightweight processes which execute within the same program, and you will have multiple execution paths within the same process, and that is why they are light. You can have separate processes also, but handling two processes will be very expensive, because context switch between the processes is very expensive. It involves lot of register variable to be saved and restored back. Instead of all that, you just create two execution paths within the same process, so that the execution becomes pretty fast. So the need for threads is you want to make applications more responsive. It means different parts of the program should work simultaneously. So we saw the application of up counter and down counter. If both up counter and down counter should run simultaneously, you should make use of threads. And as a demonstrative program, we have seen how in a banking application threads can be employed to perform deposit and withdrawal, and the two threads have to be synchronized using the mutex. So mutex is a variable which will allow you to block the execution of other threads while you are doing some critical operation like depositing or withdrawal. So if you don't put the logs, and if you try to run, you will see the output will all be jumbled up. The output will contain meaningless output. Some part of it is meaningful, some part is meaningless, like the way you see here. So if you put the logs before you start any of the operations within the threads, then the threads will be guarded against unaccepted operations in between, and you will see both the operations will run in a very streamlined way, and you will get the meaningful output. Okay, so we shall see more of these things on Monday, right?